Hello everyone, welcome back to Zeey, and today we brought an intriguing topic, Enceladus, phosphorus, and the stuff of life. Subscribe to our channel and ring the bell so you won't miss any update. Saturn's moon Enceladus is one of the finest places in the solar system to search for microbial life beyond Earth. These ice shell moons exhibit, like Europa, a distinct interaction between their surfaces and the oceans located beneath the ice. This is evidenced by plumes spraying water into space, as well as surface features indicating that these planets are almost craterless, indicating that they are periodically resurfaced by ocean water reaching the surface and erasing everything at least temporarily. There are other ice shell moons in the solar system that exhibit this type of surface geology, as well as some that do not, but they are believed to conceal oceans beneath their icy surfaces. In the case of Europa and Enceladus, however, this water is shallow enough to spray into space through fissures and geysers, making their oceans significantly more accessible for life searches than those of the other ice shell moons. NASA and other international space agencies plan to fly their spacecraft through the vapors and collect samples to determine what they contain. But studying the compositions of the chemicals dissolved in those ice shell oceans is much simpler, as we already have a data set from several different past exploratory spacecraft. Cassini, NASA's premier mission to Saturn, was one of these spacecraft. Cassini ran out of fuel and was sent on a deliberate crash course to burn up in Saturn's atmosphere to prevent any collisions in its moon system and potential contamination. This mission ended nearly 15 years ago. However, the mountain of data it accumulated during its years of service in the Saturn system continues to prove beneficial and surprising. This time, a crucial element for existence has been discovered: phosphoric acid. This is the rarest of the 6 essential elements upon which our way of life is founded. There may be other possible biochemistries that replace phosphorus with arsenic, but chemically speaking, they are inferior, and despite some false claims made in the past, this type of life does not exist on Earth. This is a significant issue in the broadest sense. Phosphorus may very well be life's Achilles heel, to the extent that its absence is a viable potential solution to the Fermi paradox. Without phosphorus, life cannot exist. Phosphorus is associated with a number of complications. The first is that phosphorus is uncommon and sporadic in the Milky Way, although this has not yet been confirmed by a large sample size. Some regions appear to lack it, which may indicate that they cannot support life. If this turns out to be true, then it is not surprising that we observe the vast silence and do not encounter alien civilizations everywhere. They may be uncommon because phosphorus-rich ecosystems are uncommon. That would imply that the search for extraterrestrial life is equivalent to following phosphorus. As an aside, phosphorus depletion is already a concern on Earth. Since at least the 19th century, countries have had to import bone meal and other substances to replenish phosphorus in their depleted soil. It is fascinating to compare nitrogen and phosphorus due to their rapid depletion in the soil, whereas carbon is the most important element for life on Earth. Nitrogen and phosphorus are the building blocks of proteins and the framework of DNA, respectively, without which life would be impossible. Nitrogen is not an issue, as it depletes rapidly, but the atmosphere is approximately 80% nitrogen, so it can be artificially fertilized or returned to the soil by microorganisms that can fix nitrogen. You can also rotate crops and plant symbiotic plants, such as beans, that contain these nitrogen-fixing microorganisms. Phosphorus, on the other hand, has no such stratagem. You must wait for fertilizer or geology, so either the Earth itself compresses and dissolves phosphorus into the environment, or we do it. And even when this occurs, a substantial portion of it reacts and is unavailable to biology. Isaac Asimov made the point in the 1950s that phosphorus is the bottleneck of life, a fact that has been known for a very long time. In fact, it remains a conundrum in astrobiology and the study of life's origins how life on Earth managed to scavenge just enough phosphorus to get going and stay alive. The answer to this question varies widely. According to some hypotheses, it may have originated from meteorites and a local impact with a phosphorus-rich meteorite that abnormally increased the levels where abiogenesis was favorable, wherever that may be. Others argue that phosphorus could only have accumulated in lakes. We simply do not know, but phosphorus must have been abundant for any miracle to occur. And returning to Enceladus. Cassini had made multiple passages through Enceladus geysers. Despite not being ideal for the task, it was able to record measurements. Scientists combing through the mountain of data from Cassini and other sources discovered the presence of the essential components of life. Carbon, hydrogen, nitrogen, sulfur, and oxygen were among them. We also know that carbohydrates and amino acids are simple to produce, as demonstrated by the Miller-Urey experiments in which nutrients, a simulation of the early Earth's atmosphere and an energy source, are combined to produce life-sustaining nutrients. Meteorites contain amino acids, the building elements of life. We observe organic compounds pervading the cosmos, indicating that life is ubiquitous. Phosphorus is the only element in issue. Phosphorus, however, was lacking on Enceladus. This element combines with sugars to create the skeleton of DNA, and the process that led to the formation of DNA on Earth remains a mystery. The good news, however, is that you only require the constituent elements. Recent findings derived from the Cassini data set indicate that Enceladus is rich in phosphorus. According to interpretations of the Cassini data, the amount is absurdly excessive. Its oceans contain 500 times more phosphorus than Earth's oceans. So that concludes it. Enceladus has now overcome the greatest obstacle in terms of chemical life components. If you have phosphorus, you have the equivalent of gasoline to power a car. However, there are some factors that may cast doubt on this. The detections did not come from a plume directly, but rather from Saturn's E ring, which is firmly believed to be generated by Enceladus's plumes, though this has not been proven and its dynamics are not fully understood. Nonetheless, vapors are the likely offender. It turns out, however, that orthophosphate is a form of phosphorus that organisms can use for growth. It's interesting because these findings contradict an earlier model that predicted Enceladus oceans would be depleted of phosphorus, though the author of that paper was among the first to proclaim that these new findings are a game changer and that they happily disproved his hypothesis. Indeed, science in action. This is how we learn and advance. Here is yet another peculiar aspect of Enceladus. It appears that orthophosphate would dissolve much faster in Enceladus Ocean than previously believed. This could literally be the phosphorus moon, and Earth the phosphorus-poor restricted life world to the extent of having 1,000 times less bioavailable phosphorus than Enceladus has. This also suggests that the oceans of Enceladus are in contact with the bedrock and are dissolving compounds from it. Previous evidence also strongly suggests that volcanic vents are responsible. However, there is an enormous query and an even larger mystery that are rarely discussed outside the depths of the history of astrobiology. The issue is that we do not know how ancient Enceladus is. Here there are contradictory data. In 2016, a paper focusing on the dynamics of Saturn's moon's orbits demonstrated that, due to tidal effects, the orbits of any Saturn system satellites inward of Titan should not be as they are. This would indicate that all of those moons, including Enceladus, are relatively juvenile, possibly forming as recently as 100 million years ago. It is important to note that Saturn's rings are ephemeral, estimated to be only 400 million years old, and will disappear in approximately 100 million years. Geologically speaking, things happen in the Saturn system. On the other hand, there is evidence that Enceladus's ocean is at least 1 billion years old, which is more than enough time for life to have arisen there. Choose your contradictory data set for this instance, but within this lurks an even more perplexing mystery. Examine Enceladus's fissures. These are likely composed of material that rose to the surface from the ocean's depths. It appears to be blue ice, similar to what one might find in polar regions on Earth. Moreover, microbial life exists in these regions. However, pay close attention to the fractures on Europa. Again, these appear to be the result of the same processes. Two very similar ice shell moans should have a similar hue, so why are they so drastically different? This is an unanswered query because we do not know what is causing it or what it is composed of. Europa is 4.6 billion years old, the same age as the solar system. It has had the same amount of time as Earth to develop life, Enceladus perhaps not. Backtrack to 2002, Brad Dalton, a planetary geologist, examined the infrared signature of this staining and compared it to algae that flourish around hot springs on Earth. Signatures were comparable. So he subjected a variety of earthly microorganisms to conditions comparable to that of Europa in a lab here on Earth. Again, the infrared signatures resembled Europa's staining, although not exactly in infrared. Some have suggested that salt mixtures may be the perpetrator, but no salt mixture has ever replicated the results. However, there is one peculiarity. The staining coincidentally shares the same color in the visible light spectrum as a prominent Earth bacterium. Alright everyone, this video ends here. Thanks for your attention. If you find this information valuable, give it a thumbs up, subscribe the channel for regular, in-depth explorations of the fascinating, strange and unknown facets of this incredible universe we inhabit.